Okay, then rotation off. I have written rotation off.
Sir,
Good
today
morning,
you are
everyone.
looking smart, sir.
I'm looking smart. In what sense?
Yes, sir.
Okay, since I wear this, worn this, it's giving me a lot of trouble, but I'm trying to adjust to it. So let's see that. I think not able to adjust it properly. I don't know why. Okay, lecture number 5, and we are dealing with rotation. Up till now, up till now we have dealt with equilibrium. The last class we had dealt with problems on equilibrium. We had seen what happens when the body is in equilibrium. Two types of equilibrium we have seen. One is known as the rotational equilibrium, one is known as the translational equilibrium. For
Translation.
translational equilibrium, net force is zero. For rotational, net torque has to be zero. Now, in today's class, what we are going to see is what happens if the torque is not zero. The torque is not zero, then what will happen? The torque is not zero, then what will happen? Any idea?
The body will rotate about its axis or a
Yes.
fixed point.
Body don't rotate about points, body rotates about axis. So if the torque is not zero, the body will start to rotate. The body may still be rotating with a constant angular velocity. If torque acting on the body is not zero, it will start rotating with a angular acceleration, and that is what we need to see. You can write the heading torque. And what is if the net torque? What is this? If the net torque acting on a body is not zero, then the body will have angular acceleration. Then the body will have angular acceleration. It will rotate and its angular velocity will keep on changing constantly. Do we understand this?
Yes, sir.
Now, how do you find out its angular velocity? Then you can use this equation. Which equation? Torque along the axis will be equal to I along the axis multiplied by alpha along the axis. This equation can be used to find out the angular acceleration. For example, angular acceleration along that axis of rotation will be given as tau along the axis divided by I along the axis. Do we understand this?
Yes, sir.
If there is torque, you can find out the angular acceleration. And once you get angular acceleration, you should be able to do the rest of the things correctly. Okay? Do we understand this? Now
Yes, sir.
remember, this equation here that we have written is for pure rotation along that axis. Now this equation looks similar to the equation that we had in translational motion. F is equal to ma. Yes or no?
Yes, sir.
Now F is being replaced by torque, m is replaced by your
Moment of
mass,
inertia.
and a is replaced by your
Alpha.
a is replaced by your angular acceleration. But there is a very big difference between the two equations. Apart from terms being different, there's also one more difference. Can you spot that difference from the way I've written the equation? I've written the equation in a way that you should be able to spot the difference. What is the difference between the equation which I've written on the left hand side and the equation which I've written on the right hand side?
That's in equation of torque, all are about one axis.
Okay.
In force, in this equation, force can act anywhere, and acceleration can be in that direction or opposite to that direction.
Basically, the difference is in this vector notation. This is a vector equation. Net force is equal to mass into net acceleration. Wherever in which direction that force is, the acceleration would be in that direction. This is a vector equation. It's valid in all the dimensions. It is valid everywhere. But this equation that I have written is only valid on the axis that we are talking about. The body can have torque about any axis, but it is not going to rotate about that axis. Do we understand this? The body rotates only about one axis about which it is supposed to rotate. It is not going to rotate about any other axis. So we might be able to find torque about infinite axis. Torque is about an axis. Torque is about a point. Body rotates about axis. It can rotate about infinite axis, but it might not be rotating about infinite axis. It might have torque about some other axis as well, but it is not going to rotate about that axis. It is going to rotate about some other axis. And therefore, this equation has to be written only along the axis. Do we understand this?
Yes, sir.
This equation should be written only about the axis. This is an actual equation. It can only be written about the axis. Do we understand this? So that is the thing that you must remember whenever we are writing this equation. Otherwise, the equation is not valid. It is not a vector equation. So if I write this equation like this, tau is equal to I into alpha. Remember, I is not a vector. Alpha is a vector. Tau is a vector. If I write this equation in this form, this is the wrong form of the equation. This equation cannot be written in this form. Do we understand this?
Yes, sir.
Because torque as a vector quantity, you can find it about any point, about anything, but the body is not going to rotate about that point. So you can understand it in that way. This is the wrong variation of the equation. This one is only the correct variation of the equation. Do we understand this?
Yes, sir.
So remember this whenever you are writing torque equation about any axis. This is not the one. This is not how you should write them. Okay?
Yes,
It's
sir.
only written about the axis. Once you get the value of torque, then you can find the angular acceleration and then you can solve any question based on that. Okay, let me make a question and let's see if you can solve this. So here is the question that I am going to make. Suppose this is a disk. Oops, why it is going here and there. Suppose this is a disk. It is hinged about its center O, so it can rotate. It is rotating. Let me use a different color pen. It is rotating about this axis with a constant angular velocity omega. You must have seen a grinding wheel that your grandmothers might have used. A grinding wheel. This is a grinding wheel which is rotating with an angular velocity of omega. Now I have to stop this grinding wheel. How I'm going to stop this grinding wheel? How can I stop this grinding wheel? The mass of this is m. This is a disc and the radius is r. Yes, how can I stop this grinding wheel? Yes, how can I stop this grinding wheel? No one has any idea? Think about it. Let me know once you know the answer. Yes, how can I stop this grinding wheel? It's such a difficult question. Okay. I'm going to stop this grinding wheel by applying a force, obviously. I applied a force like this, a constant force F. You never saw how to stop a grinding wheel? How do you stop the wheel of a cycle if it is rotating? How do you stop it? You apply a force in the opposite direction, you stop it. Anyways, I've applied a force F. You have to find out the angular acceleration of this disk and the time it takes to stop. You have 2 minutes to do this. Anyone understands the question?
Yes, sir.
Right.
Angular acceleration find out. Sir,
Yes.
sir, it is 2F by M into R.
2F by?
Sorry, minus 2F by M into R, sir.
How much time will it take to stop? Is it such a difficult problem?
No, sir.
Then why are you not able to do it? Shall I do it?
Yes, sir.
You can't do this problem. That means something is really very wrong with everything that we have done so far. Anyways, solution. If you can't do such a simple problem, how much is the torque? About which axis it is rotating?
Axis O,
What is the torque about that axis?
F into R.
Well done. That must be equal to what?
I axis I around the axis into alpha around the axis.
How much is I?
MR square by 2.
Mr square by 2. That is F into R. From there you will get the value of alpha. So what is the value of alpha?
2F by MR.
So it was so difficult for you to find this out? 2F by MR. Everyone is looking here and there, searching for the answer. So difficult? You don't know how to find out torque? You don't
Sir,
know the moment of inertia of this?
alpha we found out, sir, but time we couldn't find out.
Oh God! You know alpha. You know omega. You know final omega. You just cannot find time. Oh God! Such a difficult question. By God. By God. The most difficult question in the entire universe is this. I know alpha. I also know omega. I also know final omega. I just cannot find T. So difficult question. Such a difficult question. This is the most difficult question in the entire universe that I have seen. That I know alpha, which is constant. I know omega. I know the final omega that time taken to stop, but still I cannot do this. Must be such a difficult question in the universe. Oh God, why so difficult question come? Alpha is given, alpha we have found out, omega is given. We know the value of so difficult question. Oh God. God help me. Please God help me. Please come and help me. I know omega initial, I know omega final, I know alpha, but I can't find time. Because I've never done a question like this before, nah. Where alpha is known, where omega is known, we have to find time. I've never done a question like this. I've never done a question like this in my entire life, my dear friends. So I can't do it. I just can't do it. Isn't it? For the past 2 months, we have been doing this. And still you don't remember the equations? Now, how will you remember it? If you can't remember the equation which has been told to you at least 1,000 times, if you can't use that equations, my dear friends, what will you use? And this is in this chapter. This is lecture number 1 in this chapter. I again repeated the same thing. Still you don't know. See, Gajnis only look good in a cinema hall. If you become Gajni like this, there's no point of me taking your class because your exam is still 5 months away. You will not remember anything. You can't remember anything 3 classes before. What will you remember 5 months from now? You see, when did I tell you? I'm showing you the entire class. When we did this. See, I'll show you. See, I'm showing the entire class. Rotation about a fixed axis, this angular displacement. Again, I told you the entire thing. Rotational motion, this. This is in the same class number 1. After that, I did moment of inertia. Don't remember what we had done 2 class before. Entire circular motion we have done. Before that, entire 1D motion we have done this. Don't remember it. Oh God. God help me. Anyways, God is not going to come and help us because He just doesn't have time for us. Because in India only there are 150 crores of us. God cannot be there everywhere. So now since I can't get the help of God, so I will help myself. So I'll apply this equation which I have forgotten, which I have never used in my entire life, but I'll use it first time now. Omega 2 is equal to omega 1 plus alpha t. This is the first time we are using this equation in our entire lives. Not a problem. You can do it for first time now also. So my omega 2 here, because it has to stop, is 0. My omega 1 anti-clockwise, so it is positive omega. My alpha is clockwise, so it is negative. So I can find out the value of t from here, my dear friends. Omega divided by alpha. Alpha is 2f by mr. And that was the answer that I was looking for. Nothing else, nothing more. But the problem was we had not done this equation omega 2 is equal to omega 1 plus alpha t. My fault. Sorry for this. I should have told you this equation at least once before this solve. Beta, this is the equation that we have to use. We have not used it up till now. We have to use it here now. Please remember this. This was the first question. Welcome to rotation. The only thing that scares in rotation is the scare itself. But that scare can be more scary if we don't remember simple things. If you don't remember simple things, things are going to be scary. Trust me. Well, there are no questions of this category. I just made a question so that you can solve it. Anyways, now the question that are going to come, I hope you remember this now after so much of drama that I did. Will you remember it? Yes or no?
Yes, sir.
Once you get the value of alpha, which is constant, this is a question of simple circular motion or rotational motion. You don't have to do much. You will not encounter this question. Maybe you encounter this question because normally in rotation, they only ask alpha because they assume that once you know alpha, you should be able to do what you had done before. Anyways, this was a question of just one body in pure rotation. Now, such questions are very few because those questions we have already done in our circular motion. We have already done in pure rotation where we had done 1 or 2 question of this type, and I can't go back back. We have done these questions. What we have to do now is a question where just not one body is involved, where maybe 2 bodies are involved. But before going on to that, we can do one more thing before going on to that, so that we can do that thing here also. We can write the next heading, rotational kinetic energy. We'll complete that, and so that we can do one problem here as well. Rotational kinetic energy. Rotational kinetic energy. Now, when a body is in pure rotation, because it has omega, it also has kinetic energy, yes or no? Now, I'll not go into details of how this kinetic energy is derived. The rotational kinetic energy is because of pure rotational, and this rotational kinetic energy RKE can be very easily written as half I. Remember, I is about an axis. I about the axis into omega square about the axis. So if you know about which axis that body is rotating, you can write this equation. I did not have to write axis. I'm just writing axis so that you understand that everything is about an axis. We got this? This is rotational kinetic energy. This might remind us of something that we have done before. What does it remind you of? Does it remind you of anything? Anything else? So, a similar term that we studied somewhere else?
Kinetic energy.
That was, or that should be known as TKE. What do you mean by TKE?
Translation kinetic energy.
Or I should call it TRKE, translational kinetic energy, half into m into v square. But now here we are going to deal with, so let me write it as mv square. If it is a point object, it can be written as half mv square. If it is a rigid body, a system of particles, then what will I write? This is the equation half mv square, which is applicable for any particle, any body. But right now we are dealing with rigid bodies, and they are going to rotate as well as move, and so instead of writing it as half mv square, the better way to write it as when it becomes valid for rigid bodies as also half m v com square. Do we understand the difference that I made?
Yes, sir.
We have just replaced that v as vcom, because we understand that the velocity of the center of mass of the system tells us the translational motion of the body. Yes or no?
Yes, sir.
So I can write it like this. Now someone asks you what is the total TKE, total kinetic energy of the body. It will be the sum of rotational kinetic energy plus translational kinetic energy. Do we understand this? Yes or no? Okay. This might not be the time where we'll be using this work energy theorem, but let us keep it here only. Uh, we can also write the work energy theorem now. How does the work energy theorem look like? Just write the work energy theorem. How will the work energy theorem look like? Work kinetic energy theorem. The work kinetic energy theorem still remains same. It says that the work done by all forces is equal to change in kinetic energy. But you must understand here that in this work done, it is work done in translational motion, as well as this is work done for rotational motion. This change in kinetic energy will be change in translational kinetic energy. This will be also change in rotational kinetic energy. Do we understand this? Yes or no?
Yes, sir.
Or we can break this work into two parts: work done in translational motion, work done in rotational motion. Then we can break this kinetic energy into two parts: translational kinetic energy and rotational kinetic energy. So I can write this mother theorem in like two daughter theorems. So I can say work done by all translational forces will be equal to delta of translational kinetic energy. Work done by all rotational forces will be change in rotational kinetic energy. Do we understand this? Yes or no?
Yes, sir.
Now, when I talk about work done by translational forces, so work done by translational forces, for any transitional force, you can find it out as F dot dr. Yes or no? That is the work done by transitional forces. Yes. or no?
Yes, sir.
Hmm. How do I find the work done by rotational forces? So you can write it as tau dot d theta. But again, remember tau can be about any axis and rotation can be about any axis. So instead of writing it like this, you can write it as what? Tau into d theta, and we must only calculate tau about the axis where the body is rotating, and you must also rotate and you must also calculate d theta about the axis. If this tau is constant, tau means torque is constant, then you can write the work done by this rotational forces as tau multiplied by the angular displacement. Yes or no? It is similar to here. If the force is constant, you can write down the work done by translational forces as F into delta R. Yes or no? Or F into delta R into cos theta. Here this cos theta wala term will not come because we are not going to deal with a case where torque is going along this axis and body is rotating along this axis, because I've already told you you have to find out torque along the axis. Do we understand this? So even if the torque is like this, you have to find out the component here. Do we understand this? So the moral of the story is very simple. And what is the moral of the story? That everything that we did in translational motion has its counterpart in the rotational motion. If you understand the transitional motion, you should be able to solve any question in the rotational part. Do we understand this? Yes or no?
Yes, yes, sir.
Let me go back. Let me go back. Let me go back to this problem which created all the drama. Find the work done by this force. For only this question, I have told you all this Ramayana. And don't ask me who is Ram. Ram is the prince of Ayodhya, the son of Dasharat. And Kaushalya. Kaushalya, no? The husband of Ma Sita, avatar of Vishnu, born to kill Ravan. He was Ram. But here we have to find out the work done by the force. Let's see who can do this. And you have exactly 2 minutes. And if you can't do this, then you will get all philosophical things from me. Let's see who gets me the answer. You have 2 minutes. Any answers? Well, don't worry if you can't give the answer in so much time. There is no chance that you can give it anytime soon. How do you find the work done? This body is only under rotational motion, so I can do it in two ways. And those two ways are not different, they are actually same. Way number one, work done by all these rotational forces is change in rotational kinetic energy. Change in rotational kinetic energy, final kinetic energy is 0. Initial kinetic energy is half I omega square. So work done will be minus half I is mr square into omega square. That is the first way of doing this question. Do we understand this? It was not difficult, it was simple. Anyways, you could have done this in a different way. Work done by rotational forces is tau multiplied by delta theta. How much it has turned? Tau. Tau is F into R. F into R multiplied by how much it has turned. How will I find out how much it has turned? So I can use this equation, my dear friends. Delta theta omega 2 square is equal to omega 1 square plus 2 times alpha into delta theta. I can find out how much it has turned. Alpha is negative. You'll get the answer as negative because the work done by this force is negative. To find out the value of delta theta from here, omega 2 is 0, omega 1 is omega, alpha is f into r divided by m. You can write this value or you can write this value. F and f will get cancelled, and at the end of the day, what you will get is same minus half mr square omega square. Because you must understand that this equation here is nothing but we have applied law of conservation of we have applied work energy theorem. This is nothing but the work energy theorem. This is nothing but the work energy theorem. So everything comes from one equation only, and the answer would be minus half m omega square into r square.
Sir, it is I is mr square by 2, no, sir.
Yes, yes. So one will be by 2 also. Correct. My fault. That is how you have to do it. The easiest way, I guess, is to find out the change in rotational kinetic energy. If you don't want, you can do it that way also. So that was it. Note it down. I know that you probably have not understood this, but please note it down because you might get the same question in the examination hall. If you have any doubts, please ask. I'm very disappointed by the way you are doing questions today, not applying your common sense. I think the change of time has not worked for you guys. So I must think about changing the time back again to the original time, because in that time you were doing questions brilliantly. Now all of a sudden I don't know what has happened. Whoosh, everything has just gone from I don't know from where to where. Anyways, think about this, understand the question, give it some thought. I'm here, don't worry. We have time, we have enough time to complete your course. If there's anything that is troubling you, that you have not understood beta, forget about my dramatics. If you are not able to solve a simple question, I just get dramatic. But that is just to make you realize that we have done this, nothing else. We've done those things. And we don't have so much time that we can do things 5 times. Even this rotational, we have done 3 times at least. With circular motion, we had done the same thing. When I started rotation, I still again repeated it once. Don't have so much time that we can do those things so many times again. Anyways, do it. If there is any doubt, please ask. Else I will move on to the next category of questions. Shall I move on? Have you noted it down?
Yes, sir.
Okay. Okay, that is how we'll go. Now let us move on to, since we are doing rotation on a fixed axis, rotation will be on a fixed axis, but now since there's only one body, there's only one type of question that can be formed. We have already done those questions. Now we'll be doing questions where more than one bodies are involved. But the motion that we are going to study will be rotation on a fixed axis for one body and translational motion of other bodies. So this is case number 2. And now we'll write case number 2. Rotation about a fixed axis and translation of other bodies. So this is again a combination of translation and rotation, but here one body will be rotating and the other bodies would be translating. How are we going to solve question like this? So just to give you an example, what type of question will come here, there would be a body, let us say like this, a disc. Now this disc is hinged about this point, and we will be doing this question. This disc will be hinged about this point, and then it will be having some rope which will be wound around that disc, and then a mass would be hanging from that rope. So this is this body, the pink body. Pink body would be in pure rotation. Do we understand this? This pink body is in pure rotation, nothing happening. It is a rotating. And this green body would be in pure translation. Do we understand this? Huh? How are you going to solve such questions? Steps for solving. What will be the steps? Step number 1. Isolate the bodies and draw FBD. When I say FBD, you must draw all the forces. Do we understand this? Huh? Then the system will not be in equilibrium, because equilibrium questions we have already done. The system would be having some acceleration. Yes or no? So for the translational body, you can find the net force, and for the translational body, that net force must be equal to m into a. Yes or no?
Yes, sir.
This equation would be made for this body which is in transition. Now, there could be one body in transition, there could be two, or there could be more. So for each and every body, you have to make this equation. Do we understand this? Yes or no? So make
Yes,
that
sir.
transitional. I'm not writing everything. I don't want to write everything. I'm just showing you that for the transitional body, you have to find out the net force and equate it to their acceleration. Do we understand this? Then for the
Yes, sir.
rotational body, what will you do? Huh? Rotational body, what will you do? Nothing, sir. I'll sit and relax and have a cup of tea, and things will happen. What will you do for the rotational body? Or body which is in rotation? We'll find the net torque about that axis which is rotating and equate it to I into alpha. So from this you will get few equations. But again, there will be a small problem. What will be the problem? What would be the problem? The problem would be this alpha and this A. You have to establish the relation between this alpha and A. Now, how would you establish the relation between alpha and A? For that, you will need constraint equation. Constraint equation for no slipping condition will be applied to get relation between what? Huh? Alpha and A. It might not be said, but if the question is framed correctly, they will always give you this condition that there is no slipping, no slipping, no slipping between the rope and the pulley. If it is a
Yes.
question of rope and the pulley, they will tell you there will be no slipping. If it is a case of a cylinder rolling on the what? On the ground or on a plank, they will tell you that there is no slipping. If there is slipping, then this last equation does not come. If there is no slipping, then only this last equation comes. Do we understand this, or is it going above and saying bye bye? I'm going in today's class. Everything is going above my head.
We got it, sir.
Welcome to rotation. That's what rotation is. Everything goes above the head. Trust me, this happens not to students. This happens to the biggest of teachers. Everything goes above their head. I don't understand anything. Is everything going above your heads? Above your heads, everything going. Then if everything is going above here, I will not do any question on this type. So there is no point of doing it since everything is going above your heads. Okay. So then I'll move on to the different questions. Okay. Shall I?
Yes, sir.
Okay. So I've told you the way to do this, and then we'll move on to different questions. We have understood this work energy theorem, yes or no?
Yes, sir.
We have understood how to find out rotational kinetic energy.
Hmm.
We understand how did we do this question?
Yes, sir.
Okay, then we move on to this question then. This is a disk whose moment of inertia is given as I and whose radius is given as R. So we'll just solve this question and then we'll move ahead. A body of mass m is hanging on this disk by a rope which is wound on this disk, and there is no slipping between the disk and the rope. So what will happen now? This system, I am holding this system. There is a disk, there is a rope, and from this rope, this mass is hanging, and I'm holding this. What if I leave this mass? What will happen? I'm holding this disk or I'm holding this mass. I leave this mass. What will happen?
Sir, please could you repeat again, sir?
If I leave this system, what will happen? Will it remain like this?
No.
What will happen? There is a disk. This is not a question of physics. This is a question of common sense. There is a disk. There is a rope. There is a pulley. Let us say, not a disk. It's a pulley. It's a pulley, and you have rope wound along this pulley, and the other end of the rope is attached to this mass.
Mass.
This pulley can rotate about this point, about this axis O, and I leave this pulley. What will happen?
Uh,
This is no physics involved. This is common sense. There's no physics here. Don't worry. We don't know. Okay. This block will come down with,
yes.
let us say, an acceleration. Is it so difficult to understand? And this pulley will start to rotate with, let us say, a constant angular acceleration alpha. The question is, find out the value of alpha and A. The question is, find out the value of alpha, which is the angular acceleration of the disk or pulley, and A. So moment of inertia I is given. So what is given to you is m mass
Mass.
for the pulley, which is the pink one. We have given moment of inertia I and R, and it is also given that there is no slipping,
Yes, sir.
and you always know G because we are living on planet Earth. We know G. So these are the things given to you. Now apply. Do you want me to do this? You can do
No,
this.
sir, we are doing.
Okay. So how are you supposed to do this? Well, I've already told you the way. This is the way to do it. Take your time. There is nothing new. You have already made the equation of block hanging from a rope. You've already made equation of a disk which is rotating. The only thing you have to do now is to put them together. That's it. You have done so many questions where there were two blocks attached to a string. You had made the equation of those blocks. Remember it. Just now, I gave you a question where you had to find out the torque due to a force on this disk. You have done this. You know how to draw free body diagrams. That is all that is required to solve this question. So I'll wait. Take your time. I'm in no hurry. The important point is that you understand what you are doing. The important point is not to cover the course. If I want, I can finish rotation today. In 20 minutes, I can finish rotation, whatever time is left. So it's not about finishing your course. It's about doing things in the right way, doing
Yes.
things in the way that whatever we do, if a question comes from that part, we are able to do this. That is the entire concern that I have. Don't worry. Don't worry about your course. I will finish it 1 month before your exam. Try it with your own hands. The only reason I am asking you to try it because that will give you confidence. I can do this in 1 minute, but that will not serve any purpose. So try it. When you try it, you understand what you have not understood. You only understand that when you try. You don't understand it when I give you the solution. Because then whatever I have said, that gets imprinted in your brain. I don't want to imprint anything in your brain. I want your brain to think in that way. If your brain starts to think from the very first question, every other question you will be able to solve because your brain will start to work. Nothing else. You already know the process. You just have to make the equations and you are done. Nothing else you need to do. Chalo. No one is able to do this? Then I'll do it. Listen, and the first thing is draw a free body diagram. So I've drawn a free body diagram. This is T,
Tension, this is mg.
this is mg. This tension will apply on this body as well.
Yes, sir.
If you want to draw the free body diagram of the pulley, you can draw the weight of the pulley as well. But there is no point of drawing the weight of the pulley because weight of the pulley is actually not doing anything here. It will only give you the hinge reaction, which I don't need.
Yes, sir.
And I can make the green equation of this block. What is the equation of this block?
mg minus t is equal to ma.
Mg minus T is equal to Ma. That is the first equation.
Yes, sir.
What is the equation of this green pulley? This pink pulley?
And
T into R is equal to I into alpha.
yes, sir.
Now you look at the number of unknowns and you look at the number of equations. T is unknown,
Mhm.
alpha is unknown,
Yes.
and A is unknown. That means there are three unknowns, but there are only two
Two
equations.
equations.
So you must get one more equation. How will you get that one more equation? You'll have to apply the condition of no slipping. What is the condition of no slipping? Look at this pulley and look at this rope. Now remember, this rope is going down with an acceleration A,
Yes, sir.
and this pulley is rotating with an angular acceleration alpha. If I take 2 points, point number 1 on the pulley and point number 2 on the rope, they must have the same acceleration downwards, otherwise they will slip over each other.
Yes, sir.
Acceleration of point 2 is A in the downward direction. Acceleration of the point 1 is alpha is angular acceleration, alpha into R in the downward direction. If they have to move with the same acceleration, both of these accelerations must be same. That is the equation that I will get from the condition of no slipping. So from the condition of no slipping, I get alpha into R is equal to A. Three equations, they can be easily solved. How they can be easily solved? You can put the value of alpha from here into this equation, A by R, and then you can add this and then you can divide this equation by R goes here, then you can add up these two equations, T will get cancelled and you will get the value of A in
Yes, sir.
terms of the known quantities. You divide A by R and you will get the value of alpha. Can you tell me the value of A and alpha? What is the value of A and alpha? I'll give you 1 minute. I think 1 minute is good enough to solve this. Yes, what is the answer?
1 minute, sir. Karthik ఏమొచ్చింది?
Solve it fast. Okay, so the answer would be this: mg divided by m plus I by r square. That is the value of your a. To get the value of alpha, you just divide the entire thing by r. So mg by r into m plus I by r square. That would be the answer that you would be getting. Note it down so that I can move on to one more problem. Have you noted it down?
Done, sir.
This is the next problem. You have two blocks, M1 and M2 now, attached to the same pulley. The moment of inertia of this pulley is I. R is the radius of this pulley. M2 is greater than M1. It's a rope which goes on the pulley, and you must understand that there is no slipping between the pulley and the rope. You understand this?
Yes, sir.
What if I leave this system, then what will happen?
Acceleration due downwards. It will fall down.
Which will fall down? What will fall down? Both can fall down, na?
It will leave the pulley.
It's not a problem of physics, it's a problem of common sense.
Karthik.
M will be falling down, sir.
Which M beta? Both are M.
M2. M2.
M2 is falling down. If I say that the acceleration is A, what will be the acceleration of this block?
That will be also A, sir.
Chalo, thank God. So it will fall down with A. This will move the way. What about the pulley? Is anything happening? Is going anything happening? Going to happen with the pulley or not? No, the pulley remains like this. Remember, there is no slipping. No slipping. What will happen to the pulley? Does the pulley rotate or not? Does the pulley rotate or not?
Yes, sir. It will.
How will it rotate?
Um,
Clockwise or anti-clockwise?
Clockwise.
It will rotate like this. No.
No, sir.
Okay. It will rotate like this. Okay. Let us say that this is alpha. So now you have the question. M1, M2. You know how to write the equation of M1 and M2. You know how to write the equation of the pulley. Everything is there in your hands, my dear friends. Your future is in your hands. This question is in your hands. The mic is in your hand. The pen is in your hand. Now solve it. You have 2 minutes to show me your talents. Yes, but Chinese answers. No answers. Get answers. Shall I do it for you? Time is running fast and furious. So how are you supposed to do this? Anyone able to draw the free body diagram? Yes or no? No, yes. So I draw the free body diagram. This is M2G, yes or no? This is T. This is T. Not able to hear you. This is T. This is T. And this is M1G. Yes or no? You got this free body diagram? Yes or no? Well done, my dear friends. Then I can make the equation of this blue. Oh, sorry, this pink, pink. Yes. What is the equation of this pink thing? Okay, you can't speak, so I will speak for your behalf. I can see M2G minus T is equal to M2A. Yes or no? No, yes. Everyone got this? Well done. Then I make the equation of this block, green block. Everything green, like Hulk, just like Hulk. What is the equation of this block? The green block. Going up. T minus M1G is equal to M1A. Yes or no? Two equations. Two unknowns. We are done. Yes or no? That means the pulley does not rotate. Something is wrong. This question is same as that Atwood's machine, which we had done. Two equation, two variable done, but here also the pulley rotates. How can the pulley rotate? As long as the tension on both sides are equal, pulley cannot rotate. There is no friction on the pulley. That is why tension is same, and that is why the pulley does not rotate. But here the pulley has to rotate because there is friction, and therefore, my dear friends, the tensions are different. So this becomes T2 and this becomes T1. So this becomes M2G minus T2 and this becomes M1G T1 minus M1. Do we understand this? The tensions have to be different, otherwise the pulley does not rotate. And this is the question of Newton laws and not rotational motion. Do we understand? Now, remember this T2 is greater than T1 and that is why this pulley is rotating like this. Wee. Now, again I have how many unknowns I have? I have three unknowns, two equations. Then I will make the equation of this blue pulley. Yes or no? Yes or no? I will leave that to you and to give me the answer when I come and meet you tomorrow. Do you understand what has happened here? What is the problem here and what is the problem there? When the pulley does not rotate, tensions are same. When the pulley rotates, the tension has to be different. You understand this? Good luck. Solve this problem, get the answer, and stay happy. This question is exactly similar to the one question that we had done before. The only thing is two tensions. Don't worry. You will be able to solve them by the same process that we had done in the previous case. So I'll leave you with this problem. Tomorrow, the first thing in the morning, the first thing that you will tell me, sir, we have done this problem. Yes or no? Try. I don't want a correct answer or a wrong answer. That's not my concern. My concern is that you try. That is the only concern. And you have the sheet. Try questions from that sheet. Only those questions will be coming in the exam. I can assure you that. So I'll see you on the other side of this week. That means on Monday. And probably by the end of this coming week, we will be done with rotation once and forever. And we can move on to simpler things in life from the next to next Monday. So that will be our intention of finishing rotation by the end of next week. Everything that is possible, I'll do it. And I hope that you can keep up with rotation, because rotation is a topic no one understands. So don't worry if you don't understand it. Even I don't understand it. But if there are simple things that you can remember, and if based on those simple things, questions come, you should be able to do them. Do we understand this? That is the only thing you have to understand. Simple question comes, then only you can do rotation. If a difficult question comes, the only person who has said that question would probably be able to do it. And that too, he may be wrong, because he might have missed some point. We've seen even questions in IIT have come wrong, right? So if a tough question is made, if I make that tough question, trust me, only I will be the person in the entire universe who could solve it. So we can only understand those questions which are easy, and we should be able to do them. Okay, take care. I'll see you in the next class. Bye bye. God bless you all.